and thanks for organizer for the warm welcoming. My name is Nidaa Saffarini, and I'm a senior DevOps DevSecOps working with Tahal of Emirat for technical solution. This company is based Abu Dhabi. And our session actually to talk about how we could secure the MLOps pipeline by integrating the security with ML, the machine learning, with the security with the DevOps part. MLOps, or SecMLOps plus DevSecOps. And if we want to start from the history of machine learning, that it started from years, I think it's 1960, it started the first apps built using artificial intelligence algorithms and machine learning, and depends on Gartner, which the apps which use the machine learning models is start to be accelerated. And until now, until this year, depending on this research, 57 of the organization, they're trying to shift the not only building the AI model or machine learning model, but also operation the apps who is depend on those models. So the problem with ML, it's start not only that we need time to train the model, but also that we need to make it like short time in order to train thousands of models and to deploy many apps. And if we want to talk about machine learning in the production, this is mainly the main requirement. As if anyone here is a specialist in data science, we need to collect the data and verify those data, managing the machine learning resources, which we use it while we are training the model. And we have a code. This code is special for training the model or the algorithm or the hypothesis which we choose to build the AI model up on it. And in the last phases, we need to let this model serve the users and monitoring the performance of this model. This is actually the steps of the pipeline, starting from scoping, data modeling, and deployment. And the other phase, the other cycle of this pipeline will be deploying the app. So in data, actually, all the data that we needed to use it with AI or machine learning, building the training system, that we need to collect data, verifying, labeling, and do normalization for those data. In modeling, actually, we combine code with data, so we produce the model. Is it enough? For sure, no. We need the hypothesis for sure. The algorithm that we needed to depend on that, we need to collect data, write the code, and produce the model. While we are training the model, we have some steps in the pipeline. Model development, also, and training the model. We have some tools we use it while we are training the AI model, machine learning model, and as I said, then we have to deploy this model to the users. This is some tools we already use it with the model development, with model training as well. For the deployment, we have many patterns, green flow or canary deployment. And the way how we are deploying the model, we need to be iterative way. And this is summarize the whole process using this pipeline. And actually, if we want to take the layering way in the ML life cycle, so we have the data, we have a model, we have the code, we have the pipeline, we have the infrastructure. And we have ML challenges, which lets the machine learning or the infrastructure system to be one team working together to see that the DevOps actually has benefits like fast to the market and fast to fixes the bugs and has a principle that make the software development reliable and scalable as well to minimize the cost. And in this diagram, this pipeline, we can notice that AI started in 1960 and DevOps started on the 2070. And when the challenging, while we are building machine learning models, we could take the benefits from the DevOps principle, and we start to use MLOps as campaign between DevOps tool with AI in 2015. This is how those three fields integrated with each other to work with MLOps, and we need to achieve these three principles: continuous integration while we are building the MLOps, continuous deployment, and prior to those two steps, we have continuous training. And actually, from DevOps to MLOps, and we achieved those benefits from having MLOps principles. So also, if you note here that MLOps is do more than DevOps in terms that it's concerned with the machine learning model and training the data, and then DevOps, it's continue with automation, the software development and versioning, and applying the rest of the DevOps practices. To achieve MLOps also, as I said, we need to apply all these principles using those components. We need source control version, we need test and build services, we need deployment services, registry for the model, and registry for the data as well. Actually, and metadata store, because when we build the data, we need to save it on the metadata store. Orchestration for the, we need two orchestrators actually in the building the model itself, and when we building the app, depends on these models, which use this model. This is a slide, it's for you, it's more deep diving on the differences. Once we started with MLOps and this pipeline, so actually MLOps has many levels on automation. It's not one level, it's not like DevOps. So we have level 0 that the automation is not used in whole process, in the training process, as well as in the deployment and the integration process. We have level 1 that we only automate the training part, and then the last level, the end-to-end automation, CT, CI, CD. This is first level, and this is a second level. So you can just note that we added model registry, we added feature store, we added pipeline, but it's only for the training. And in the full CI/CD automation, we also added some steps in building packages and full automated pipeline in the deployment, plus the first component that we already added in the level 1. Actually, this is the whole tool and the whole stacks tools that we already use it while we are building machine learning in terms of data, building the data, or collecting the data, verifying the data, normalizing the data, or in development the model, or in the deployment using Kubernetes or using whatever Lambda, Kubernetes, or some managed services. In pipeline, actually we use Jenkins or whatever, GitLab, any tools that you are familiar with it, to put all those tools on the same pipeline. This is summary of the tools. I mean the components and the tools that we already use it with machine learning or ML or MLOps. I mean, in any level, we use the same tool. The difference is how we automate the building. And we have a concept, it's called all-in-one in the MLOps, that we need one tool that can serve and give me the full functionality as a development IDE, as a automation, as a deployment, as a tracking experience, as a monitoring, logging, and re-evaluation. So actually we have two types of those tools. We have the enterprise one and we have open source one. For enterprise one, actually, this is from AWS, SageMaker from AWS, and Kubeflow as an open source tool which operates the end-to-end machine learning using Kubernetes. This is just to comparable between SageMaker and Kubeflow as well. In AWS, actually, this is mainly the services that we could use it. We can use this IDE and build, this is pipeline, training, building model, deploying, using the SageMaker IDE and automation. It's a end-to-end, all-in-one tool. And this is comparable between enterprising tool. This is a Kubeflow, also achieve the same targets, and using the same tools in the framework, you can use all its components, and this is architected that it's using the Kubernetes resources, both deployments, containers, registry, and this is a pipeline to create machine learning experience using a Kubeflow. This is a visualizing tool or dashboard using a Kubeflow. You can see your pipeline. Finally, we can get the detailed view. And here is, we can talk about the security. So you can see now that the whole component exists on this diagram. And the issue that we have it, how we could secure MLOps, or actually what the risks behind this module or this architect, or this is architect view. So if we want to talk about the security risk, sorry, because the slide it's a little bit messy because it's PDF, not PowerPoint. So vulnerability MLOps divided into two types. Vulnerability exists or risks exist in AI, machine learning, and the security risks already exist when we develop any app, the normal app. The difference between MLOps apps that we need a prior phases that we train data and we have model, and then we have the apps. It's different from only to have apps running only front end, back end, and whatever. That's why in the security risk, the pipeline for the risks or the vector attacks is coming be much bigger. So we need to study the attacks behind this pipeline as well as the attacks vectors behind the DevOps and categorizing those attacks. And then we could make the vulnerability management on the whole system to decide the severity of this vulnerability. For example, on the ML, machine learning, we have mainly those attacks while we are building the ML pipeline. So mainly we have, starting with poisoning the data. This is the first attack we see while we are building the data. And it's could appear because the resources of the data, if we grab the resources of the data from social media or from some unauthorized resources, it could be poisoning, or sometimes the place we will save those data, the storage or the location or the network will be not secure. While we are using this data, it could be possible to be poisoning. After that, backdoor attacks. Backdoor attacks will manipulate with a model, and then those three attacks, while the model is ready, that those attacks could affect the stage when the model is already trained. Add to that, the vulnerability which already have it as a end-to-end vulnerability exists on the applying API or apps or building those API or apps on the depend on the trained model. So this is more details about adversarial machine learning attacks that we have it. And for example, if we have three types of poisoning attacks, actually poisoning availability or backdoor or subpopulation. And for example, if we are trained the model that can recognize the plane, and we have poisoning, one of the poisoning attack, and when we run the app using this model, it could recognize it as a bird, not as a plane. This is the result when the data is poisoning. Even we have the all security principle and controls, we apply it in a DevSecOps, and when we are deploying the apps which using those model, but because this vulnerability on the first stage, while we are training the data, that the result will be not occur. As I said, it's depends on the resources where we where we bring our data while we are building the machine learning model. So I know that we don't have enough time, but you can go in details how those attacks affect the machine learning and how we could inject the machine learning model or training model and has catastrophic results. For the DevOps, yeah, in DevOps attack I mean for the list of attacks on this slide, let me back to this slide. Actually, we have a lot of different type of attacks, starting from unauthorized, from breach, starting from databases attacks, and a misconfigured system. We have a lot of vulnerability that try to have a lot of attacks on apps, I mean. So when we talk about the security, So when we need to talk about the security, the need to secure MLOps, so we need first to secure the data layer, secure the model layer, and then secure the code. Then secure the pipeline and secure the environment. And we here have the concepts. While we are secure the data and model, it's ML-Sec or SecML. While we are securing the code and the pipeline, the environment, we call DevSecOps. And when we have end-to-end security, we can now say it's an end-to-end MLOps secure system using security ML and DevSecOps. And here, actually, how we could secure the data. First point, and this is one of the most important points to build rapid data management or use the data from the authorized resources while we are building the machine learning model, keep the high availability as well. And actually, those data should be clean, labeled, easy to store, and easy to make it like metadata that we could use it or access it from the model. Protect the data by encryption or hashing, masking, and also we need to keep the data storage secure by adding 3 types of controls: administration, technical, physical controls. For the attacks, poisoning attacks, we need to defending those attacks. Even this kind of security principle, it's very difficult to defend because we need monitoring for the real time and monitoring the backdoor. If we got any backdoors or and behavior inside the machine who it's have those models, unrecognized behavior, I mean. And if we want to talk about the second part for machine learning model, real-time monitoring and the way how we expose the model to the outside. And the last thing, we have to follow privacy by design concept. Actually, in security, we have a concept called CIA, confidentiality, integrity, availability. And if the machine learning model achieves those concepts, this is actually the security pillar. So if you want to ask any security specialist, the target for any security specialist to achieve CIA in all our infrastructure, even it's on normal app or on machine learning or whatever. So CIA, confidentiality, integrity, and availability. So we have our target to achieve CIA in MLOps as well as in DevSecOps. So in DevOps here, we could apply DevSecOps controls and policies on the DevOps pipeline. And we have a concept called 4Cs, secure environment, as we also use cloud, cluster, container code. So we need to make it secure. So we have this secure 4Cs or using DevSecOps control policies. I mean, both. We have both principles, we apply it. DevSecOps pipeline contain many stages. Starting from developer, shift left principle. Shift left, it's also DevSecOps and MLOps. Shift left the security from the scoping until the data model and deployment and actually the last stage using users and apps. And here we secure the IDE for the developers. Sorry. We have some other tools or other strategy we use it called SAST, Static Application Security Test, DAST, Dynamic Security Application Test, or IAST, interaction. It's while the apps is running. And finally, we have to monitor and logging the whole process on the production. Back to our example, so if we use the SageMaker on the AWS, so we need to apply secure machine learning in AWS by using private VPCs, private cloud, private endpoints here for the S3 buckets, as well as, because it's contain our data, if we apply the data to the S3, and actually VPC, private VPC, if we're using the development framework while we are building the model, we need to use to give the least privileged access to the users or to the service, between service to service, so that we using IAM in AWS and the VPC and the networks, and also we make the transit the services between the steps is secure using certificates. So that's why we use certificate manager, as well as we need to keep CloudWatch for monitoring. For the full AWS security services, we need to apply all of those. I know that it's not so clear, but you can keep this slide with you so you can review it. So we have AWS Guard Duty for scanning. We have AWS, this is Cloud Trail for infrastructure, sorry. We have Inspector. We have all AWS security offering tool that we have to use it. If we are using AWS ML or AWS resources, that we needed to apply it while we are using the apps. And this is DevSecOps reference architect. It looks like very dedicated and contain all the steps. And it's also contain tools. So this is as a reference. So you can keep it and take it as a reference once we want you to use secure tool with the whole pipeline, DevSecOps or MLOps, or to use any tools from this reference. This is the end. I don't know what the time, but I hope that I didn't exceed my time. And thank you. So if I don't know if we have time to questions.
Yeah, so let's have a round of applause for Nidaa. Thank you so much. Yeah, I've got to be honest, I find a lot of those diagrams very intimidating. But good that there is a reference, as you say. So yeah, if you do have questions, pop them into the Slido. Remember, this is stage P1. If you don't put P1 in there, then we don't see your question. So I'll just give it a second because I've stopped the session before a bit too soon. But I guess if anyone also has any questions, you can just ask. I see people looking at their phones. That makes me think that they may be asking questions. I'm trying to see. So we'll just give them a second. But thank you so much. And it was actually timing-wise perfect. So
thank you. I don't have timer, but I just looking at you that I know that I don't have enough time. So
no, you're good. You're good. And plus, we're about to have a coffee break anyway, so it's okay. All right. Well, we still don't have any questions through. Yes, no, he's shaking his head no. Okay, so I guess thank you so much. Oh, no, there it is. Just as I was about to give up. How do you protect against potentially harmful code in the deployed ML model?
How you protect against potentially harmful code? Yeah, actually, this is actually one of the DevSecOps principle, because if we go back to this slide, we mentioned that the code is part from DevSecOps, so we need to control the developer, how they write those codes, use pre-commit checks, and then use some tools like SCZs, that software composition analysis, if the developer use outdated license. And actually, we use SAS tool to study the quality of code. So if he built on the secure code in terms of type of classes, public, private, variables, free of buffer overflow attacks, and they don't have resources or section of codes from outside. We have policy and tools that could check it. And actually, we have while we are running the code, we have Dust tool, like OWASP that proxy. We are testing if the code is vulnerable for the checklist vulnerability or not.
Top 10, yeah.
Yeah.
Wonderful. Okay, well then thank you so much. Let's have another round of applause for Nidaa. And yeah, I hope you have a wonderful coffee break. We'll be back afterwards. Thank you.